We have another power supply for repair, an MS titanium 400V1. It's smoking when you plug it in. I'm not going to plug it in because I already did it once and my entire room smelled like burnt electronics, and I don't want that. We'll take it apart and see what we can see from the inside. Well, that's nice. If you have a look at this IC right here, we see that it is an UTC 494. It is a fairly common control chip used in these power supplies. Typically, you don't see these two big charge resistors next to this IC. So let's have a look at a different power supply. This is also an MS Industrial, but it is way older and way better designed. See, it also has the TL494 chip. It is the exact same, but a different manufacturer. And we can see there are no big charge resistors next to this IC. And also the filter of the standby power supply does have a loading resistor, but it doesn't run nearly as hot. So definitely design fail right here. So let's try to figure out what these two resistors are doing. These are all the power supplies based on the TL494 or its analog KA7500. Those two are different name but the exact same chip. So yeah, let's go Kodegan. Kodegans are usually decently designed power supplies. So let's see right here. These two resistors go, this one goes to the pin this, and this is the 8, 9, 10, 11. This is a pin, this one goes to the pin 11, and this one goes to the pin 8 of the KA7500. So let's find the two resistors connected to the pin 8 and 11. So here we have, okay, so those are the two base driving resistors. So those two resistors right here are driving these two transistors right here. On this power supply they are hidden under this transformer. I don't know if you can see them. Those are the two resistors that go from the 5-volt standby power supply. Actually, this is the auxiliary output, which goes around I think 17 volts in most cases, and it goes to the bases of these two transistors. If we check the value of, let's check on this power supply. I'm checking on this power supply right here because the two transistors are removed and the chip is also removed, so the reading will be more accurate. Okay, so they are using a 680 ohm resistors to drive a base of a transistor from 17 volts. That's quite low. And if you have a look at what this power supply is using, they're using a 1.5 kilo ohm resistor. And if we have a look at the older, if we have a look at the older power supply, that's this resistor right here. They are using a 7.6 kilo ohm resistor. So as you can see, there is absolutely no need to drive a base of a transistor with such low resistance resistor other than making them run hot. These big resistors cost way more than these small ones, and you're putting extra load on the both IC and these two transistors, as well as extra load on the power supply right here. So there is absolutely no reason for them to use these kind of resistors other than the failure. They want the power supply to fail as soon as possible. And same goes for the loading resistor. As you can see, this power supply, the loading resistor, which is right here, first of all, the loading resistor is nowhere close to the first capacitor after the Schottky diode. So this is the first capacitor after the Schottky diode, this is the coil, and this is the second capacitor. The loading resistor is nowhere close to the first capacitor. And as you can see by the strange lack of burn mark under the resistor, it's not running nearly as hot. So this power supply is basically designed to fail. And I've seen many of these power supplies. As you can see, this one had the same problem where these two capacitors failed and the power supply stopped working. Even though I fixed it, I decided not to put it in use because its design is so horribly made that it's just going to fail soon anyways. So in this case, I'm going to try to fix this power supply, but this power supply will not go back into service. It will be used for parts. So what happens on this power supply, because the entire filtering of the standby power supply, which is this capacitor right here for the auxiliary, and these two capacitors for the primary output of the standby power supply, they are feeding the chip. The chip is getting very noisy power, and it's in best case cannot start, and in worst case I've seen this chip fail short circuit. So let's see, let's have a look if this chip is still alive. So here we have VCC is pin 12 and ground is pin 7. So if we go to diode test, this is a pin 1, 2, 3, 4, 5, 6, 7. So this is a pin 7. Pin 7 is ground, which is right here. And the VCC is pin, this is 8, 9, 10, 11, 12. So this is the positive, and this right here is the negative. And surprisingly enough, this chip is not shorted, so it is probably still alive. So what we have to do is we will have to resolder this resistor right here, which broke because it was running so hot, and we will have to replace these three capacitors, and the power supply should in theory start up. Okay, so we have two 6.3 volt capacitors. They are using 10 volts, but since these two capacitors are only seeing 5 volts, these 6.3 volt capacitors will be fine. So I'll take these two, put them here. The auxiliary power supply is a 50 volt 100 microfarad. We will find something. Okay, so we have a 50 volt 100 microfarad. We will need that, and in this power supply Okay, now let's have a look if it works. We have a power supply tester. We put it on black, which is off. We have I bridged out the connection to the passive power factor correction, so that shouldn't be an issue. And we have a 5 volt standby. And interestingly, it doesn't work anyway. So let's have a look at what voltage is going to the power supply. We have 60 volts, which means we have an overload somewhere. Oh. So we have 10 volts on the output of the standby power supply. Well, that's not right. So not only did this power supply kill itself, it probably also killed the motherboard it was attached to, because the motherboard was expecting 5 volts, it got 10 volts. So pretty much everything that ran off a 5 volt standby power supply, including the anything that was connected to the USB ports probably got cooked because of this power supply. Now the common reason we will have over voltage like that is this capacitor right here. So let's have a look here. Yeah, ESR 9.1. Let's have a look at it now. We still don't have power, but the inverter isn't screaming at me, and we have 303 volts on the input, so there is no more overload. And if we have a look at the 5-volt standby, we will see that it is now actually 5.12 volts, so it's perfect. It is as it should be. And if we measure the auxiliary, or 9, 10, 11, 12, if we measure the supply voltage of the IC, it's 14.6 volts, and that's good. That's how it should be. But we still don't have power. Why don't we have power is a good question. Why would we not have power? This capacitor right here could be the reason. Well, let me see what. Let's see what that capacitor is doing. We still don't have power. Why? .3. I think this chip is cooked. Okay, so I had a little break. I got something to eat, and now let's discuss how I figure out the chip is faulty. Now typically when the power going to the chip is not good, typically the chip shorts out and you get a short circuit between VCC and ground. I already checked that, and that wasn't the case. In our case, we had this supply line go way above what it's supposed to be. This auxiliary power output of the standby power supply was way higher than it's supposed to be. That means way more current flew through this resistor to these internal chip transistors, and that's the flaw of this specific design, because on any other power supply the chip would have survived that, because these resistors are way way higher value than 680 ohms. So what I did here is I probed between ground and pins 8 and 11. Since the power supply was set off, I was supposed to see ground both here and here, but what I saw is around 2.3 volts on the pin 8 and absolutely nothing on the pin 11, which meant that there was clearly something wrong, because since the power supply was switched off, the voltage on these two pins were supposed to be identical, and I got something different. So what I did next is I took a diode test and measured between pins 8 and 9, and I got the typical voltage drop of a collector to emitter transistor, and pins 11 to 10 I got a direct short circuit. So I concluded that this chip right here is faulty. So I found another motherboard also from a power supply. It's a similar looking board, but it's way better designed, and it's using the KA7500. This is a TL494, but this chip will absolutely work here. So let's get to work. It looks like I made a mistake here and I forgot to desolder these last two pins, because they didn't look like, yeah, it was these last two, and I noticed after I snapped this one. So we will have to fix that, but chip should be fine. If we flatten the pins like this, this is a pin from a resistor. So let's fix that real quick. Put some solder on the chip, put some solder on here, and just like that we have our pin back. We shall continue. Power, and oh. I mean, now it's trying to turn on, but there is something still stopping it from doing so. What would that be? Oh, it could be because there is no load on the output. Let's get the fan. Yeah, it works now. And we have the stand, we have the power OK signal. Sounds very bad though. Anyway, this power supply isn't going into service anyways, so I won't bother too much with it. So there were so many failures on this power supply. So first, this standby power supply right here runs very hot on the primary side, and it baked this capacitor right here, causing the output voltage to rise up, which killed the primary control chip, this one right here. Other than that, we also had these three capacitors fail because of their dodgy placement right next to a very hot running resistor, and those were these three capacitors. And this capacitor right here, I'm not entirely sure what it is for, but it was open, I mean it was reading few picofarads, also probably because it got cooked by this resistor right here. And now it's making some weird noises, but it does work. Okay, so I did a bit more cleaning after I did some more cleaning, and you see now the power supply runs fine. The issue was there were more broken solder joints around this spot. So if you take a look right here, I did some work here, and now the power supply works fine. I also opened the power factor correction. Now all I have to do is put the power supply together and it's fixed. Okay, so here's the power supply all put together. You see it's the same power supply. It says it's 400 watts, but it's only 240 on a 12 volt rail, so that's not cool. Now we'll give it full power, 220 volts mains. It's off, and we have power. It now works absolutely fine. So it is fixed, but as I said, I'm not going to use it in a computer because it's a big piece of shit. I mean, maybe in a future video we can try to improve some aspects of its design. Then it should in theory be a decent power supply, but as it stands, it's a big piece of shit. So that's it. avoid these MS titaniums at all costs. They will all fail. This one only survived for around 3.5 years before probably killed the motherboard by sending 10 volts into the 5 volt rail, and it started smoking. So yeah, that's it. See ya.